Recently, a new phenomenon has emerged that unites a lot of the big ideas of CS principles. It deals with global impact, the internet as a distribution medium, and some forms of big data as well. So the topic of crowdsourcing, or the mob effect, is something that's been in the news as a result of social media. So if you go to a concert now, back in the old days, people may have flicked a cigarette lighter during the encore. Now everybody has their cell phone up in the air. So you go to a concert and you'll see a scene like you have here. In fact, I've been to some acts where they actually choreographed the different places where people were sitting in the stands and doing certain kinds of interesting things with the audience with phones. So, this kind of mob effect occurred just recently. So within 8 years ago was the first definition that occurred in Wired magazine. So the rise of crowdsourcing. And crowdsourcing refers to this idea of where we outsource a very common task to a mob or a group of distributed people, and the folks who are in that mob really don't even know each other. They just have a common thing that they're supposed to do, and together they can solve the scale of a large problem. One of my favorite apps is GasBuddy, which I've been using for several years now. So imagine you had to take the task of trying to find out the price of gas at all the stations across your city. And if you did this alone, you'd probably spend the entire day going and finding out the gas prices, which then change the next day, and you have to do it all over again by yourself. So what GasBuddy does is it takes the entire populace of a city and uses everyone to help find out the prices of gas at many different gas stations. So together, a large mob of people can collectively find out the gas price compared to just one individual doing it alone. And there's an incentive here because those who participate also have access to the best information in terms of gas prices. And there's also a chance to win prizes. There's an incentive built into this that is compelling the mob to react in a certain way. So Eric Raymond produced a commentary on how open source software is developed. So software that's developed by a large number of people in an openly viewable way versus those who develop software in a small team in a very closed kind of environment. And Raymond would say that a large number of eyes on that software would eventually reveal any kind of errors or bugs. And his approach in a book he wrote called The Cathedral and the Bazaar documented these two different approaches. So in the cathedral, we often have a small number of people who over a long period of time, maybe decades, or even those within the same family may work for centuries to produce a large work, for example, a cathedral, versus those who create a bazaar, which might be a large collection of people who just openly and in public view create structures that can be evolved over time. And there's a good example of how this worked in terms of a comparison when we look at dictionaries. So if you consider the case of Noah Webster, who spent almost his entire life creating a dictionary of 70,000 words, it was primarily produced from his own sole effort. And then if you look at the comparative work of the Oxford English Dictionary, this is one of the largest compilations of words that's ever been assembled from millions of different submissions, resulting in over 600,000 words being defined. And so the large case of being able to compile the words also created some really interesting situations. For example, the creators of the Oxford English Dictionary wanted to honor the person who submitted the most number of words. So they found someone who submitted over 10,000 words, and when they went to honor that person, they found out that he was actually committed to an asylum for the criminally insane. So you have all kinds of different interesting backgrounds and characteristics when you take the bazaar approach. But the idea is that many different people can contribute to a larger work that actually may have more quality built in because of the number of eyes that are watching it. And this is similar to Wikipedia. So we've been talking about this on Piazza. There's been a nice discussion of whether students should be using Wikipedia or not, and there's been views voiced on both sides. But Wikipedia basically is crowdsourced knowledge collection. And sometimes this is really good, but sometimes it might actually fail. But the really interesting thing is when it also fails, the large number of people who are watching this can correct it fairly quickly. So there's a really interesting situation about 8 years ago where my alma mater crossed with my current employer. So I'm a graduate of West Virginia University, and I was a fan of their football team growing up. And at one point, University of Alabama tried to hire away the West Virginia University coach. So I was very interested in this topic, and I was following it on Wikipedia. And in fact, if you look at the slide being shown here, there was one point that evening where a lot of fans for the University of Alabama took the photo of Rich Rodriguez and actually doctored it up with Photoshop, made all these changes to his Wikipedia entry, and declared him the new coach of the University of Alabama, only to find out the next day that was not true. So that actually corrected itself very quickly. So another kind of interesting thing of the ability of the mob to self-correct whenever an error is displayed. So Luis von Ahn invented the idea or coined the term of human computation, which has a lot of interesting characteristics to crowdsourcing and the mob effect. So human computation is when there's some computation or some kind of activity that humans do really well that computers can't. And if we crowdsource that, the collective knowledge and the skills of the humans can provide some new information in a social media style or some other kind of way of collecting the knowledge that will gain new kind of information overall. An example is the CAPTCHAs that Luis is very famous for. And when we have a case to create a brand new computer account, we have to often enter a CAPTCHA so that spam bots are trying to find new kinds of usernames or logins or trying to create new accounts are thwarted by that. So they can't actually do the type of vision recognition that a CAPTCHA would present, but a human can do that fairly easily, at least in most cases. So there's an interesting relationship between some of Luis's earlier work and how Google was trying to index images. So imagine if I went into Google and I tried to search for the two words beach ball. Immediately, within less than half a second, Google, in this particular slide, found for me 532,000 different images of beach balls. So the question is, how did they do that? How did they find all these different photos of beach balls of all kinds of sizes and colors that have been placed up on the web? Well, there's several ways that that's done. Oftentimes in an HTML page, we can put an alt tag to give metadata about what the image is about. There may be information around the figure. For example, a figure of a beach ball on a web page with the word beach ball all around. One interesting way, though, is an alternative that was explored maybe 8 years ago, was the idea of von Ahn's ESP game, formerly called the Google Image Labeler, would have two individuals who did not know each other meet on the internet, and they would be presented with an image. It would be some image that was taken from the web, and they would be presented with some taboo words that are some words that they're not allowed to use, and they would each have to then come up with a word that describes the image that they're seeing, and when both of them select a word that's the same, then that picture is done. So that in that case we found a commonly agreed upon word that two people who don't know each other would have used to describe that particular image. So that can then be used as an index for that image. There's a lot of other examples of these kind of applications. So Duolingo is trying to translate the web into many different languages and using the idea of language learning as the motivation. So people who are trying to learn different languages can help crowdsource and text translate the web into different languages. Another example is Foldit, where there's a fun online puzzle that helps with the idea of protein folding, where humans can do this very well, but computers can't. So making it a fun game engages people and helps them solve various problems in science. One interesting thing is the Amazon's Mechanical Turk. It's not exactly what you might call crowdsourcing, but it's like a marketplace for human skills. So individuals can go out and post any kind of skill that they would like and post a bid on that, and it would help to find from within a mob of people those who would be able to fulfill that skill. There's a very specific subset of crowdsourcing called citizen science. So citizen science is when we allow a large group of the populace to help us collect information for scientific purposes. So you can see a definition of that here on this slide as a systematic collection analysis of data. And the whole idea is instead of one or a few groups of scientists going out and trying to collect information, instead we involve a large number of people, equip them with a smartphone app, and ask them to help us and give them some incentive for doing that. So we actually did a few of these projects at the University of Alabama. I just briefly mentioned when we had the Gulf oil spill 4 or 5 years ago. We had a project with Vanderbilt and Virginia Tech where we were having people along the Gulf Coast help us to collect information about sea life that may have washed ashore. And then that app actually was then turned into a version called the Tornado Damage Tracker that was used to help civil engineers collect and analyze information about tornadoes. So what makes this work? So there's some sort of super-linear scalability where the mob itself is much more impactful than each individual by themselves. So there's obviously a need for incentives. So everybody in the mob needs to have a reason for participating. And the idea of various talents, often things that humans can do well, that's distributed across the world or a certain locality. Social networking infrastructure that can help collect all that information is very useful. And so you might want to talk about these things with your class and challenge them to think about what other characteristics kind of help hit the sweet spot that make these types of crowdsourcing applications work. And you might also, on the other side, what kind of scenarios would lead to failure? So what would make, for example, instead of Gas Buddy working, what would have been some situations where Gas Buddy would have failed? What things may not be present could hamper the adoption of one of these approaches? So another thing is the actual correctness of the crowdsourced solution, whether it's a Wikipedia page, as we saw before, or maybe a competitor at Gas Buddy is always going next door and trying to tell everybody that their competitor's gas is $5 a gallon. Now, how do we sample out and pull out those kinds of false information that's being passed on through these kind of approaches? So some of the things that might be useful to ponder and ask your students to think about is how can this idea of human computation, crowdsourcing, even citizen science, how do these things have the potential to help us in many different ways? So even though they can't maybe have the skills to implement that idea yet, have them think about certain ways that they might apply these ideas so that they could create an app if they knew how to that would bring some new kind of benefit to the world. Also, what's the dark side of human computation? Are there some kinds of applications of this that's evil or could be used in the wrong way? And what are the incentives that can be used to engage a mob and to help them participate or feel more compelled to participate? And then the issue we just mentioned about verification of results. So what if someone is purposely trying to enter incorrect information? How do we deal with these? So again, this is just one topic that you might spend a day on, where the whole concept of overlapping big ideas comes into play, from global impact to the internet to big data and other algorithms that help to compute these things. All these things are useful in a discussion of this topic of crowdsourcing and the mob.